Hi, welcome to another 2016 build video. Would you like to improve our dialer experience, or maybe bring the Smart Dial feature to your region, or just simply make it easy for users to contact your customer support from your app? Well, we'll be talking about the new call-in APIs to make this possible, and hopefully more things that we can't think of. I'm Bayo Olatunji. I'm a program manager on the calls team, and I'll let my partner introduce himself.
My name is Sage Schreiner. I'm also a program manager on the calling team with Bayo. Today, Bayo and I are going to talk to you about how to make a dialing application using our public calling APIs. These APIs have been available for UWPs starting with the Windows 10 fall release via the Mobile Extension SDK. They're intended to replace the older Silverlight phone call task API. The public APIs are used by our Microsoft Phone Dialer application that's built into the operating system. Some of the features of these APIs include initiating a cellular call without a per-use consent, support for dual SIM phones, and some common events and background tasks that might be useful for a dialing application. In general, dialing applications will make use of some common features. The first thing we'll do is enumerate available lines and identify the line intended for dialing. This could be as simple as making use of a default line provided by the operating system, or as complex as a picker provided for the user. Dial or dial with options is then called on the line in question, passing in a phone number that was acquired via contacts, call history, a dial pad, or some other means. Some dialing applications will also register for background task triggers. You can find our documentation on MSDN, and there's a complete sample application on GitHub. Bayo is now going to walk you through the sample application and show you how it works.
Thank you, Sage. So as Sage mentioned earlier, there are two key ingredients to building an application that can make phone calls. First is phone lines, and the second is the dial methods. Let's start with phone lines. Phone lines are essentially, think of it as the SIM slot on your device. On dual SIM devices, you're going to get two of them. Just something to note, on Windows Phone, we consider VoIP lines to be phone lines. But later in the demo, we'll teach you how to filter those out. A phone line comes with a bunch of properties. These are to ensure you have all the information necessary to successfully place a phone call. Some examples of the properties are the OS-friendly name or the line color. These are just some basic personalizations to help you build richer applications. And then you have the current line network status. Examples of this would be no service or no SIM. And then you have the can dial property. And this is supposed to help you, this is what we use later on to filter out the VoIP lines that we do not want on the cellular application. And so let's jump to the demo. So here we have our sample app on Git. And I'm just going to give you a very quick overview because this is what we're going to use for our demo today. So on the first tab is the line properties for the single line device. On the next tab is just a proof of concept phone book. Then the next tab is a simple dialer. And the last tab contains the voicemail information for the chosen line. Let's go look at some code and see exactly what this thing is doing. So we're going to start in our callininfo.cs file. This file is a singleton that manages all things line related. And let's scroll down to the initialize callinInfo async method. This method gets called when the app is launched. And what it does is it enumerates all phone lines, like Sage mentioned earlier. It then keeps track of how many lines exist, so I can manage this. This is basically for dual SIM purposes. It then picks a default phone line and makes it the current line. And then the last thing it does is it updates the first tab that you saw in the app earlier with the line properties. The two sub-functions methods I like to call attention to are the get phone lines async method and the get default phone line async method. Let's take a peek at the first one. So the get phone lines async method, as you see, returns a dictionary of phone lines. What is it doing? So the first thing it does is it gets the phone call store, and then it calls a watcher pattern on the phone call store to listen for line initialization and destruction. And then it iterates through all the phone lines it got from the store here and uses the can dial property to filter out the VoIP lines, because VoIP lines cannot dial out. And the last thing it does is it returns a dictionary of the phone lines we care about, which would be the cell phone lines in this case. So let's get out of this and talk about the second method I want to point out, called the get default phone line async method. This returns one phone line. So let's take a peek. As you see, this is a lot shorter than the previous one. And if you do not need to enumerate phone lines or manage multiple phone lines, All you want to do is just make a phone call, so you need a line. For example, the scenario I mentioned earlier where you have a app that has a button that says call contact support. This is probably what you're going to need. All you need to do is call get default line async on the phone call store, and we will return you a line to help you succeed at placing phone calls. So let's get out of that. Now, just to iterate, the initialize calling info async method enumerates through phone lines, filters out the VoIP lines we do not want, keeps count of how many lines we need to manage, again for dual SIM purposes. Then it gets a default phone line, which we set as the current phone line. And then lastly, it updates the first tab with all the line information for the current phone line. And so just a quick recap. Let's switch to our slides. So I just talked about the get phone lines async method. This is to help you enumerate through phone lines and get a list of all the lines we have on the device. This allows you to manage multiple phone lines if that's what you care about. The first thing it does is it gets the phone call store. It calls a watcher on the store to listen for line initialization and destruction. And then it iterates through the lines it got from the store and filters out the VoIP lines using the can dial property. And then the next function I called out is called get default line async. Again, if you don't care about managing multiple lines or enumerating through all the lines we will provide you, and you just want a line so you can call something right now, then this is all you care about. This is a method for you. So now we have lines. So let's talk about the second ingredient I mentioned earlier, which are the dial methods. We've provided you two ways to call dial on a line. The simpler is called dial, and it takes in a phone number. Optionally, you can also take in a display name. The second, the more flexible one, is called dial with options. This takes in an object called phone dial option, and it can allow you to do things like manipulate the audio routing endpoint. You can pass in a contact. So an example use case is if you want to initiate a phone call on speakerphone, you would use the more flexible dial with options. Now let's look at some code and see how this works. So we're back to Visual Studios, and the file we care about this time is called, let's remove these break lines first, dial_viewModel.cs. And if you scroll down to the dialer number heap method, the line I like to call attention to is the one that contains the dial on current line async method. This method invokes the dial method, the simpler method I mentioned earlier. So I'm going to press a breakpoint here, and let's run the app and see what exactly happens. Okay, there we go. And now our amp is launched in debug mode. So let's go to the dialer tab and dial 555-1234 and hit call. For those who are wondering, that is not my number. So here the breakpoint's been hit on the line we care about, the dial on current line async method. So let's step into it and see exactly what's happening. Yes. So here we have the dial on current line async method. It takes in a phone number, which we got from the dialer, 555-1234, and a display name, which I hard-coded in the previous, the call-in method as Microsoft Contact. So first we do some basic sanity check. We look to make sure that a phone line does exist, and we make sure that a phone number exists. If the two things are true, then we call the dial method on the phone line that we like to place the phone call on, and we pass in the two parameters. So if everything goes well, when I hit continue, a phone call should be placed, and we should see this in action. Here we go. A call has been placed to Microsoft Contact, the display name, and the number is 555-1234. And as you see, now we have a phone call going. Just to note, our emulator does allow you to make phone calls in case you want to test this. So let's end the call. Now let's go back to the dialer_viewModel.cs file. And I'm going to stop debugging mode. Now I'm going to replace the function or the method I just called with another one that does call the more flexible dial with options method. Let's place a breakpoint there, and let's run the app and see what happens. This method is called dial on current line with speakerphone async. As you can guess, the goal is to dial a number with the speakerphone active. So let's see if that's actually what's going to happen. Again, we go to the dialer tab, and then we dial 555, but this time 4321. Let's hit call. Here we go, breakpoints. We're at the breakpoint. And let's step into the dial on current line with speakerphone async method. Yep. So here we are. Again, this also takes in a phone number and a display name like the previous method. And we do our basic sanity check. We make sure that there is a current phone line, and we make sure that there is a phone number to dial. But now we're creating these phone dial option object. We call it calling options. We're setting the phone number for the phone dial option to the phone number we got from the dialer. We're setting the display name to Microsoft Contact, which again I hard-coded from the previous calling function. And then the key point is we're setting the audio endpoint to speakerphone now. So if all goes well, the call should be placed to the number we dialed, the display name should be shown, and the call should be on speakerphone. Let's see if that's what happens. Here we go. The call's been placed. The speakerphone is active to 555-4321. Success. So let's end the call and let's go back to our slides. So quick recap. We just talked about the dial and dial with options method. For those who just simply want to make a phone call, the dial method is probably good enough for you. All it takes is a phone number, and optionally you can also put in a display name. And then for those who want something more flexible, like manipulating the audio endpoint when the call starts, you have the dial with option method, which can again takes in a phone dial option, which could take in contact, audio endpoints, and more. And that ends our live demo for today. Now, our sample app does not register for any background triggers, but that shouldn't stop you. Some examples of some background triggers that could improve your app are the new voicemail message background trigger. As you can tell from the name, it has to do with voicemails. So when the user gets a new voicemail, this trigger notifies you of that so that you can show this in your app. And then we have the call history change trigger. Again, our sample app does not use call history APIs, but these are available to you. If you care about tracking the user's phone log, this trigger helps you keep track of that too. And then we have the line change trigger. Remember when I talked about lines having a bunch of properties? Whenever any of these properties change, we would like to notify you, and this trigger does that. Thank you. And I'd like to pass this back to Sage.
Thank you, Bio.
You're welcome.
There's a few things to keep in mind if you're working on a calling application for Windows 10. Calling application needs to declare phone call in the manifest, or when it calls dial, the OS will reject the call. Additionally, a calling application needs to have UI present in the foreground when dial is called, or again, the OS will reject the call. If you want to publish your Windows 10 calling application to China, and your manifest targets the fall Windows 10 release, initially your application will fail certification in China. Contact your Premier support representative and they'll help you get a waiver. The next version of Windows is going to implement a privacy control on a per application basis. This will forego the need to get a waiver to publish in China. This is pretty similar to what you see today for calendar, email, contacts, location, and so forth. There are a few related functional areas which might be interesting for a dialing application. These include call history APIs, which allow the dialing application to provide a view on the OS call history database. Applications that want to use call history APIs need to declare phone call history public in the manifest. You can find documentation for call history APIs online and a Build 2015 video. Another area that might be interesting are call origin and spam filter APIs. You can find documentation online and full sample apps on GitHub. You can help us prioritize what to work on in the next version of Windows. We have some ideas, including call control, support for calling on additional Windows platforms. Let us know what you think would be most useful for you by making your voice heard on user voice. Today, Bio and I walked you through what it takes to make a calling application on Windows 10. Thank you for your time.
Thank you.